Hey there! So have you ever stared at a homework problem trying to figure out how to get from kilometers to meters? Or maybe you've heard a word like picogram and just thought, what in the world is that? Well, if that sounds familiar, you are in the perfect spot. Today, we're going to totally demystify the metric system. And trust me, by the end of this, these prefixes are going to feel like your own scientific superpower.
I mean, just think about it for a second. The scale of the universe is absolutely wild, isn't it? We've got things as massive as the moon, and then things so tiny you can't even see them. If you tried to write those numbers out with all the zeros, you'd be writing for days. There has to be a better way, right?
Well, of course there is, and it's called the International System of Units, or what pretty much everyone calls the SI system. It's basically the universal language for science and tech all around the world. And it's this incredibly elegant system that's built to handle any scale you can throw at it. The secret? A really simple set of prefixes.
All right, so here's our game plan. First, we'll talk a little more about why these long, clunky numbers are such a problem. Then, I'm going to give you the ultimate cheat sheet for metric prefixes. After that, we'll start doing some simple conversions. Then we'll tackle the part that usually trips people up, area and volume. And finally, we'll use our new skills on some really cool real-world stuff. Ready? Let's do it.
So yeah, those numbers. Writing out the mass of the moon or the width of a virus is just clumsy. It's a total pain. And that's exactly the problem these prefixes were invented to solve. They're just a brilliant little shorthand that lets us chop off all those extra zeros so we can focus on the number that actually matters.
So, let's get right to the good stuff. This right here is your cheat sheet. And I really mean that. Don't look at this and think it's some long list you have to memorize. Think of it as the secret key that unlocks this entire system. It's your new best friend. You know, the best part about this whole thing is how simple it is. See that base unit in the middle? That can be anything. Meters for distance, grams for mass, liters for volume. If you go up the ladder, things get bigger. Kilo is 1,000 times bigger. Mega is 1,000,000. If you go down, things get smaller. Milli is 1,000th, micro is 1,000,000th. It's all just powers of 10, which really just means you're moving a decimal point around. That's it. Now, you might be wondering, how am I supposed to remember the order? Well, I've got a great little trick for you. It's this silly sentence. The giant Matthew King's brother drink cold milk until 9 p.m. Kind of weird, I know, but the first letter of each word gives you the prefix tera, giga, mega, kilo, base, and then down to milli, micro, nano, and pico. It works.
All right, time to actually use this stuff. We're going to start nice and easy with simple, one-dimensional things like distance and speed. You know, just to get our feet wet and build up some confidence before we move on to the trickier bits. And I want to give you a foolproof 4-step method that will work every single time. Seriously. Step 1, you just write down what you're given. Step 2, you multiply by a special fraction that has your new unit on top. Step 3, you get to cancel out the old units and just do the simple math. And step 4, you write down your answer. Let's give it a shot.
Okay, here we go. Problem number 1. Let's say we're going 45 kilometers per hour. The question is, how many meters per hour is that? Now, notice we're only changing the distance, the kilometers. We're leaving the per hour part alone for now.
So, following our steps, we write down 45 kilometers per hour. Next up is our magic conversion fraction. We look at our cheat sheet and see that 1 kilometer is 1,000 meters, or 10 to the 3 meters. The trick is to put the 1 kilometer on the bottom of the fraction. Why? So that the kilometer units, one on top and one on the bottom, can cancel each other out.
The kilometers cancel out just like we planned, and all that's left is to do the math. 45 times 1,000 is 45,000, and if we write that in scientific notation, it's 4.5 times 10 to the 4 meters per hour. See? It works like a charm.
Okay, you're doing great. That's one-dimensional conversions. Now we have to talk about the one thing that trips almost everybody up, how to handle area and volume. You know, 2D and 3D space. But I promise, there's a simple secret to it that makes it just as easy. So, check this out. We know that 1 kilometer is 1,000 meters. So it would make sense that 1 square kilometer is 1,000 square meters, right? It seems so logical. But hold on a second. That can't be right. A square that's a kilometer on each side is way, way bigger than a thin little strip that's 1,000 meters long but only 1 meter wide. So something's not adding up.
And here it is. This is the big secret.
When you're dealing with area, you have to square the entire conversion factor. Not just the unit, the whole thing, the number included. So 1 kilometer squared is not 10 to the 3 square meters, it's the whole quantity, 10 to the 3 meters, all of it squared, which gives you 10 to the 6, or 1 million square meters. Once that clicks, you've totally got this. And the best part? It's the exact same logic when you jump into 3D for volume. We all know that 1 meter is 100 centimeters, or 10 squared centimeters. So using what we just learned, what do you think 1 cubic meter is in cubic centimeters?
You got it. You just cube the factor. It's that simple. 1 cubic meter is the whole quantity, 10 squared centimeters cubed, and that works out to 10 to the 6, or 1 million cubic centimeters. Seriously, once you master this little trick of squaring for area and cubing for volume, you will never get these problems wrong again.
Okay, now for the really fun part. We've got the rules down, we've got the method. So let's put these new skills to the test and see how they help us make sense of the world, from things that are ridiculously huge to things that are almost impossibly small.
Let's go all the way back to the moon. Its mass is about 7.3 times 10 to the 22nd kilograms. Now that's a perfectly correct number, but it's a little unwieldy. Scientists like to use prefixes to get that exponent into a more comfortable range. So if we convert it to teragrams, which are much, much bigger than kilograms, the number becomes 7.3 times 10 to the 13 teragrams. It's just a cleaner way to write it.
And what about the other end of the scale? Well, get this. Scientists estimate that the total mass of all the bacteria living in your body right now is about 2 kilograms, which is kind of weird to think about. But if you do the math and convert that mass using the weight of a single bacterium, it means you are playing host to roughly 2 quadrillion bacteria. Isn't that just incredible?
Okay, let's bring it back down to earth with something you could actually do. Let's say you're at the market, and you find this amazing-looking durian. The scale says it weighs 2,581 grams. But the price sign says $27 per kilogram. So, how much do you actually pay? To figure it out, you gotta convert.
So, how'd you do? First, we have to get the units to match. 2581 grams. Well, since kilo means 1,000, that's just 2.581 kilograms. Easy enough? Then we just multiply that by the price, $27 per kilogram. And voila! That delicious durian is gonna cost you about 70 bucks. A simple conversion, and now you know if you have enough cash.
All right, let's just quickly recap the absolute most important things we covered. Number 1, SI prefixes are our friends. They make huge and tiny numbers easy to handle. Number 2, our 4-step method is your go-to guide for any conversion problem. And finally, the big one. For area, you square the conversion factor. And for volume, you cube it. Got it?
You know, you've just learned the basics of the language that scientists use to measure and describe the entire universe. It's an incredibly powerful tool that helps with everything from grocery shopping to understanding deep space. So I guess the only question left is, now that you can speak the language, what will you measure?